let's chit-chat about your exams. I want to talk not only about the in-class one on Thursday, but compare and contrast it with the take-home, which is due next week. Because I think I set it up in a very pleasant way for you. As pleasant as an exam can be, anyway. As pleasant as an exam can be. So here's the deal. There are technically two topics on this exam. Two. There is the topic of estimating a population proportion, which we call P, lovingly call P. And there's estimating.
Is that different than the P hat?
Yes.
Okay.
Very much different. Very much different. Estimating a population average or mean, which we lovingly call mu. And the difference. Who wants to explain the difference? Christina's awesome question is for example P different than P hat? Give her an analogy. P is to P hat as, let me see hands on this, let me see hands on this. Give her a nice analogy. P is to P hat as, tell me your name again, my friend.
Natalie.
Natalie, go.
Mu is to X bar.
Mu is to X bar. P, let's do that mathematically actually. P is to P hat as mu is to X bar. P and mu are both measures of the population. P hat and X bar are both measures of the sample.
Okay.
So, yes, the trick is we want to know P and we want to know mu, but we'll never know P and we'll never know mu. So we build confidence intervals around P hat and X bar. And with 95% confidence, the parameter we're studying is going to fall within the interval. Fair enough?
Fair enough.
Now here's, if you want to think of it as far as like topic-ish things that you'll be responsible for, there's two kinds of confidence intervals you can do. There's the one prop z is. One prop z. Apologies for the marker. Sorry. One prop z in. That's the TI shortcut for single proportion confidence intervals. And then there's the T interval, which is the shortcut for the averages. I left all of these. On the take-home part, which means the only confidence intervals you're going to be doing on Thursday are these guys. So if you want to practice, if you want to do like a focused practice, focus on the T intervals for Thursday and realize all the single proportion intervals will be on the out of class one that you're going to turn in next week. Is that fair? I think it's at this stage in the game, it gets extraordinarily challenging to recognize the difference in language between whether you're testing for a proportion or for an average. So this is kind of my way of saying, okay, for this first exam, let's separate them. Let's keep the averages on Thursday, because we just got done going over them today. Keep the averages on Thursday, keep the proportions for the part next week. And once you've prepared for this one, there's a lot of overlap between what you're doing there and you're doing here. The idea of the fish, the idea of the tank, the idea of the margin of error, it's all the same, it's just a contextual difference at that point. Does that make sense? Cool? The only thing is, I did include one related question to this on the out-of-class one, but it's not a confidence interval. It's computing a sample size and interpreting a margin of error. So you're going to want to use that program sample size calc. I think you may have to use it on the take-home too. I don't remember if you do or not. I can't remember. It's been a while since I uploaded that. But I did pull a newspaper article, a Gallup poll from Gallup's website. And it was dealing with the Newtown shootings that happened a couple months ago. I wanted to use the Boston Marathon bombing to see public opinion how it's changed, but it's too recent. They haven't gotten a new poll up yet from that one. So I used the Newtown shootings Gallup poll from a couple months ago, and it asked, basically I asked you, did they sample enough people for 95% confidence and for a certain margin of error? And that's where your sample size calculation comes in. It lets you know how many you would need to do that. So basically, that's all we're looking at there.
So you said it's computing a sample size and what a margin of error?
It's based on a desired margin of error.
Okay.
It gives you this. It
Okay.
gives you a sample size that you would
Okay.
need. Yeah, Paris.
How do you get the sample size?
That's good. This guy and this guy are both under stat tests.
Yeah.
Anything I give, you have to go to program to get. PRGM, the button right under stat. And then make sure, the one thing I just want to verbalize again is when you're using that program I gave you, make sure your margin of error is in a decimal form. Your confidence can be either way, decimal or whole number. But the margin of error needs to be as a decimal. I couldn't get it to work unless I made it that way. So that's it. As far as the intervals go, I kept all these guys on the take-home part, keep T intervals on the in-class part. Just that way, contextually, you can refine your understanding of which one is which. By the time the next couple exams roll around, we'll be nailing them back and forth. Oh, it's a percentage. Oh, he said 15 out of 100. That's a percentage. Oh, he said we had to measure the temperatures at Mount Bachelor. That's a continuous variable. We're talking about an average. You'll get the context as the class goes on. Right now, I think it's still new enough to kind of freak us out a little bit. Which understandably so. I mean, it's not the easiest stuff to wrap your head around. Cool? That's it. That's it. I pulled some data sets from CNN polls, from Gallup polls, and they're very conducive to what we're doing in class. So, yeah, Jamie.
So, sorry everyone. You're saying that the SS calc is you're calculating the sample size you need according to your desired MOE?
Yep.
Okay.
You put in your maximum margin of error that you accept.
Yeah.
And it tells you how many people you need to survey or how many things you need, how many data points you need to guarantee, and no more than that. Maybe less, but no more than that.
Right.
Cool? Yeah. Good. So that's Thursday. And it won't take you the entire time Thursday. I mean, it won't. I mean, it's very much button pushing. And you can use the word overlap, by all means. You can use the word overlap. I want you to, don't let the take-home exam question freak you out. I don't expect that kind of answer every single time. I expect it only for the same reason that I made you calculate Ernie's standard deviation manually in 243 one time, and one time only. Then you can use technology, hit enter, S pops out, and you're like, oh yeah, S equals 1.5. I totally know what that means now. At least in the back of your mind you do. That's the same reason I'm having you write it out. I've said it in class a half a dozen times, what it means when the intervals overlap versus don't overlap. But you guys process the word overlap. Good, absolutely. This is my way of making sure at least once you write out what that overlap means, and it commits a little bit for the hippocampus in the back of your mind, for the posterity. I said posterity.
Partially occupies the same space.
Partially occupies the same space.
Overlaps.
I was looking for a. Oh, good, good, good. What does?
Whatever.
Well, okay. You had me at whatever. Paris, go ahead.
Well, can you give us the MOE, or should we just use like 25%?
What do you mean? Oh, for this one here?
Yeah.
I'll tell you. I'll say if you want this confidence and this much of a margin of error, what sample size would you need? Basically. Yeah, you'll know what it is. Great question. You have to know what that is in order to use the calculator. So you'll know it. Just make sure you put it in correctly. If it's 5%, don't put in 0.5. Don't put in 5. That's 500% margin of error. I'm confident that between negative 362% and 1,212%, it just gets a little ridiculous after a while.
Definitely overlaps.
Definitely overlaps. Everything, for that matter. Cool? All right, what I want you to do is I want you to sit back. I want you to sit back. Oh, let me do it over there. I want to paint the picture where we're going to head after your exam on Thursday. I want to paint a picture for you. We're not going to do any new math today. I might do a little geometry today. I might do a little geometry. Maybe. Maybe. And if you don't like geometry, you can excuse yourself. Oh, you will. Oh, I will. Oh, I will. So what I want to do first is I'm going to throw you some studies that I pulled out relatively recently. Some of these are getting old. I got to replace them. Studies show that diet may trigger adverse behavior in children. Okay, as a shocking. As an ADD child myself, I'm tempted to agree with that, especially after the story my mother. I think I told you guys a story about me and my Uncle John and strawberry ice cream. Ever told you this? The one time, and one time only, my parents went out on a date after I was born. They left me with my Uncle John. They came back from their date, I was naked, passed out on his leg. He was passed out on the couch, and there was a bowl of half-eaten strawberry ice cream soup next to him. About a week later, after my Uncle John and my Aunt Nancy vowed to never have children, they had 3 boys eventually, it was discovered that the red food dye in strawberry ice cream triggered my ADD episodes, or my hyperactive episodes. It wasn't ADD, it was hyperactivity. So yeah, I'm kind of tempted to agree with this, ish. How do you think that study was conducted? And this is a completely open-ended question for you guys.
Cracked out a bunch of kids with red dye.
Cracked out a bunch of kids with just want to make sure I get this right. Cracked out a bunch of kids with just the kids with kids with red food dye?
No, like kids that are diagnosed with ADHD, kids without.
Okay, so now I took this down the ADHD path. It might not even be ADHD. It might just be hyperactivity. It might adverse behavior, as I told Susie before. Define adverse behavior. What is adverse behavior? Tricky, but let's suppose that it is defined properly. Big assumption, those of you taking research methods classes will define this even better. But let's suppose we have defined adverse behavior as past a certain limit. Michael, go.
Well, and the other question is where did your sample come from? Did you only choose children who are prone to, quote, adverse behavior, or?
Here's my hope. I love this point. Do we only choose kids that are prone? Here's my hope. My hope is that we grabbed 2 different groups of kids that are basically essentially identical in all ways. We monitored their diets, and we classified a diet as, say, good or bad, nutritious as not nutritious, something like that. Because all it says is diet may trigger. What kind of diet? Not in the headline, as is per usual. Then we constructed confidence intervals that measured their behavior. Then we construct a confidence that measures their behavior. And what I would hope we would see at that point, and like I said, I don't know what the hell this measure is. I have no idea what this measure is. But let's say that the behavior is centered on 0. And 0 means normal behavior. Here's bad. Here's exceptionally good. Okay? And I'm making these terms up. And I should probably mute the screen so you can actually see that. I'm making these terms up. I have no idea how this metric is generated. Good night, my friend. What I would hope is, I'm making all these very broad assumptions that we got a good sample. We've defined adverse behavior. We've defined diet correctly. Here's what I would hope to have seen statistically. Good diet, quote unquote good diet, quote unquote bad diet, and non-overlapping intervals, which would tell me that there's a statistically significant difference in behavior among those on a bad diet versus those on a good diet. Bob, there are so many questions to be answered about the quality of this study, of course. That's what you're...
Yeah. Everything.
Every single point of that. I just said, take for granted they selected a good sample. Take for granted they defined behavior correctly. Take for granted they defined... So in other words, take for granted the 18,000 hours that have to go into making it to this point. You're starting to realize now, when you guys run a T interval, most of the work has already been done for you by giving you the data set. You've got a data set. You have to just crunch some numbers on it. Yay, us. That's fantastic. But you have entire classes devoted to the proper collection of it. And no, they're coming. They're on their way. Not right now. Not right now. Fair enough? Ish? Okay, good. So that's what I hope I'm seeing there. I'm hoping I'm seeing non-overlapping intervals amongst the 2 kids. We have better methods than that we'll get to as well. Study finds people who multitask often bad at it. This is a Stanford study. We're going to analyze this one in this class. They actually did a really, really tricky study. I watched my wife do things like pay the bills, watch television, and have a catch with my son, all at the same time. I could barely. You notice how I'm standing still and talking? That's not coincidental. If I tried to walk and talk, I'd break something, probably my nose. So multitasking is something I suck at, but my wife is fantastic at. And I've heard generalizations that girls can do it better than guys. What Stanford found was nobody does it well. What you essentially do is you do a lot of things all half-assed, instead of doing one thing well. And we're going to study this study in this section when we get to it, probably next week at some point.
What else tell your wife that?
What's that? Oh, I have. She's like, bullcrap. And there's outliers. Any data set has an outlier. Just because the intervals don't overlap doesn't mean we can't find a data point that doesn't live in the interval. But 95% of the time, on average, we have no overlap. Go ahead, Jamie.
You say half-assed, I say good enough.
Definitions, my friend. It's all about definitions. It's all about definitions. Vitamin supplements don't fight cancer, studies show. Studies show. Notice how this word studies show keeps coming up. Studies show. You can tell the date on this one, the inauguration. That one right there is an interesting one. because relatively recently, a study came out that said taking a multivitamin does fight cancer. One study came out that said taking a multivitamin does fight cancer. We're going to analyze that one in this class too, but newspapers picked it up. They said, oh my God, for years we've been seeing studies that show vitamin supplements don't fight cancer. And here comes one that says they do. And you know what I say to that? What do I say to that? Why do I say bah humbug? Not even looking at the data, which sucked, by the way. Not even looking at the process, which the process was good, but the data sucked. Mathematically, why did I say bah humbug? This is a very, very contextual question, Karen.
Because all the rest said that it didn't, so, I mean, it did.
How many? There is, I love what you just said, and she's right. This is the mathematical point right here. There is a percentage of correctness that we are allowed with our intervals, Michael, and that percentage of correctness is what?
95.
95% of the time, which means 5% of the time we're going to be wrong, which means 5% of the time we're going to set up an interval. 5% of the time, the parameter we're looking for is not in the tank. You see what I'm getting at there? So what I'm saying is, a result like this could very well be one of those 5%. It could be one of those 5%. I read a great article on this in New Yorker magazine about 6 months ago called "The Truth Wears Out" or "The Truth Falls Apart" or something like that, saying, look at all these scientific studies that get overturned. And I'm looking through them, they outline about a dozen. So I'm saying, well, a dozen got overturned over the course of whatever that they've reported on in 10 years. How many hundreds didn't get overturned? Do the ratio. I'm guessing it's about 1 in 20 get overturned, which would be right. 5% should be wrong. 5% of the time, you're not going to do what you're trying to do. You see what I'm getting at there? So 95% confidence does not mean we're always right. It means we've trapped the parameter 19 times out of 20. That's the beauty. So when I see something like this, over and over and over again, it's a replicated study. A replicated study. Think back to 243. What's the chance of getting 30 birds that are all roosters?
0.
Basically 0. The chance of being wrong not that the rooster is wrong, but the rooster is the rare event. The chance of getting rooster and then rooster and then rooster and then rooster is essentially 0 the more studies you look at. Michael, go.
Well, the other thing is if you take all the studies that showed it right, assume that they have 95% accuracy, the same accuracy being applied to that, ratio all those together, essentially what you have is the proof in the pudding of the 5% being wrong.
This is also one of your take-home exam questions. I have to do just this right here. Just so you know. And it's a bit of a limiter for a lot of the arguments we've done today that we'll deal with in time next week. You got it, my friend. It's perfect. Susie, go ahead.
That doesn't sell papers.
Of course it doesn't sell papers. We're talking about real mathematics and science, not economics. Sorry. Fluoride affects the brain, so don't fluoridate the water in Bend. Then I get told by my dentist I have the best teeth he's ever seen. In Delaware, I got nothing but crap for my teeth. Nothing but crap for my teeth. I moved to Bend, I got the best teeth he's ever seen. What's the difference? I don't know. Perception, perhaps. But when I found out the water wasn't fluoridated in Bend, that's when I started suspecting maybe that could maybe have impacted the belief of my teeth. I think my teeth are ugly, by the way. Breakfast makes better students. Studies show. This is related. I'm always very interested in diet.
Maybe all the people in Delaware have better teeth than you do.
Perhaps. Why?
Got
Then
money.
we see that. Then we have to go. Why? Why do they have better teeth than me?
Smile.
Just
Well, I mean, there's lots of questions, lots of definitions, lots of tracking, lots of lurking variables that we have to smile. Studies show 1 in 100 kids have autism. New number arrives on previously accepted 1 in 150. Doctors wonder about true increase. The doctor should wonder about the true increase. The reason for the increase was simple. Do you remember what it was?
Better.
Ashley?
They changed the definition.
They changed the definition of autism and they included more categories. So naturally, you put more into the pot. Now, I heard better detection. That's also true. That has happened over time. Studies of, say, Asperger's and autism that went undiagnosed back in the 80s and the 70s are now being diagnosed. But as little as 3 or 4 years ago, they changed the definition of autism and made it more broadly reaching.
It's a spectrum now.
Which it's a spectrum versus a point. So of course the percentage is going to go up. So the fact that the doctors wonder about the true increase, good doctors, please, and we get to the apostrophe out. That kind of drives me nuts too. Bad grammar. I'm sorry, Catholic school ruined me. 1 dose of H1N1 vaccine may be enough. We'll test this one in class too. I'll let this one. Remember H1N1?
Yeah.
Yeah.
Also known as?
Swine flu.
Right. How many people did it kill? Like
Almost,
12.
Almost me.
Almost you. Almost Michael.
Yeah.
I won't joke about it then.
Yeah, it was pretty bad. It was a
Okay,
lot of
good,
shit.
good. But the interesting thing was, what was so interesting about swine flu was they ran out of vaccine. So some clever British scientists ran a study that said, what if we water it down? Essentially, water it down. Like here's a bunch of vaccine, here's a bunch of water, mix them together. Will that be enough? We'll run the numbers in this class. It's interesting. It's interesting. Mental studies show coffee is good for physical and mental health.
I agree. Yes.
But if you have diabetes, beware of caffeine. Somehow, when you look at those headlines, they almost appear to be contradicting. Coffee's good, coffee's bad. Coffee is now, I've been told coffee is now a health food. This is a complete change over 5 years ago, when caffeine and coffee were said to be diuretics and therefore not good for healthy reasons. Then I get told by Julie Hood, who I admire with everything that I have, that caffeine is not a diuretic. These seemingly contradictory studies come out, but then when you read them more carefully, you realize they're not contradictory at all. The idea of caffeine is so wide-reaching that each one is only hitting one piece of that wide reach, but when you dilute it down to 80 characters, you lose that refinement in the studies. Yeah, Jamie?
Well, you also have to look at what website you're getting it from, who the author is, who they've worked for. Who
Even more! Don't stop at the website you're getting it from. Go find the source of the data. Don't stop at that website. Find the source of the data. Backtrack it. Check the fund. Absolutely. Hopefully it was done by an NSF grant. Hopefully, or something along those lines. Unbiased. That's why I question Airborne. The Airborne, the little effervescent cold remedy. One study done, inconclusive. Looks like it's conclusive on the package. Paid for by the manufacturer. Okay, great. Placebo effect. Enjoy that placebo effect. Yes?
I was going to bring in something to you that's interesting. My husband is 6'6".
Yes.
He had a doctor's appointment last week, and the doctor gave him paperwork calling him obese. He weighs 230 pounds. And
He's 6'6", 230?
6'6", 230.
Seems
But
just
their
about right.
chart only went up to 6'4", so they entered in 6'4". They didn't take into consideration. I know. I knew you'd hate it, and that's why I was like, I have to bring this in. So the chart goes to 6'4". His BMI, you know, they put down for the 230 at the 6'4". He's solid. Like he works out and he's always biking.
So BMI is going to
He's
be
all
off
muscle.
because he's all muscle.
Like 5% fat.
Did you do body surface area? BSA?
Like they didn't know.
No.
They just weighed him and took his wrong height.
Fat pinches?
Nothing.
Took his wrong height.
Yes.
So he's
now,
more than 6'6"?
He's 6'6". They
Wait.
put and then they put in his chart.
Oh, they
Yeah.
used 6'4" on the 6'6".
Yeah, on the BMI. They gave him like all his paperwork, put in his chart that he's obese.
They didn't do a caliper test
I
on him?
freak out, and I'm like, no.
No,
you
no
know,
caliper test, no BSA,
Nothing.
no muscle analysis.
Nothing.
Because with a caliper test, you can actually get the
Right.
percentage of them that's
So
not fat,
they
that's
had
lean,
to-
muscle mass versus skeletal.
They enter it into their computer with the fake stuff. And
Did you have fun with it?
Like I was so well, no, he wouldn't let me go to the doctor with me
Oh,
because he doesn't need a mom. You
let's
know,
go together.
like he decided to be independent this time, and I was
Like
like,
a picnic,
see, I knew
pack a
I
lunch.
should have gone.
We'll pack a lunch, we'll all three of
He
us go
comes
together,
and
it'll be
says
great.
he has to lose down
We'll bring
to
wine for the doctor to get drunk away from dripping
Yes, he says he has to weigh 198 pounds in order for them to get on this chart that doesn't work for his height. Anyway.
It's for me. It's always a party when I read something like doctors question true increase. Like
I just
it's
thought-
always a party for me when doctors get math right because I see something like that so frequently that they get things wrong.
Yeah.
So yeah.
I knew you'd have.
Oh yeah, it just makes me want to chew my tongue off. So anyway, I want to chit chat a little bit. Let me make sure the volume's up. This is actually kind of fun. We've got some music to listen to while we explore the beginning of the next part of our course. Let's see if we get some volume. Any no effects fans in here? Yeah, we got a couple. Yes. These guys are geniuses, statistical geniuses. And they're kind of funny too.
It's so easy to defend the status quo. Everyone's so cruel and cynical. When you see and don't justify the news, it's just that 180 degrees.
they've synopsized in one verse of one really catchy song the entire next 6 weeks of this course. I swear. And they even had a wasted line. That with everyone so cool and cynical is a throwaway line. That doesn't really count. The first, third, and fourth lines of this verse perfectly describe what the rest of this course is all about. Confidence intervals is a humongous part of this course. Humongous part of this course. And everything kind of ties back to those. But I mentioned before, Michael, you brought up a really good point about when you loop all the studies together and do what's called a family-wise error rate, which we'll get into in this class too. You have to make adjustments for the lack of confidence. One of the things I have you guys do in your take-home exam is, if you run, say, a number of intervals, all at 95% confidence, what's the chance they're all right? And you have to use your 243 multiply. What's the chance if I buy 30 birds, they're all girls? It was a 90% chance of a girl, right?
Yeah.
So it's 0.9 times 0.9 times 0.9 times 0.9, 30 times, which is essentially tails off, becomes like 25% or something like that. The same logic can be applied to statistics. If you run